So LocoMan is a very special morphology of robot. It's a combination of quadrupedal robots, just like a dog, but we also install the grippers.
The human-to-LocoMan framework equips the LocoMan robot, which is a safe, compact, and user-friendly quadrupedal platform with versatile manipulation capabilities, making it well-suited for real-world settings like home and care facilities.
The ultimate goal for robot is to enter everybody's home and help people who need help. In this case, I think LocoMan is perfect for this kind of activities because LocoMan uses the foot. So if there's stairs, it can climb the stairs. And also, LocoMan has a low center of gravity, so will be much safer than like some normal humanoid robot that has much higher center of gravity. So another application for this kind of robot is for areas that is too dangerous for a human. Landsliding could be example. So right now we send workers to climb up those slopes and place sensors. So it's actually a very dangerous job. So the LocoMan can be a perfect device for this purpose because it's very lightweighted. It's only 25 pounds. And also it's very intelligent. It has legs, so they can climb to those areas and place a sensor in those places.
In addition, human-to-LocoMan provides a scalable cross-embodiment pre-training and fine-tuning scheme to accelerate data collection and robot learning. A human can perform complex manipulation tasks in diverse scenarios using an VR set like Apple Vision Pro to collect human demonstrations for pre-training.
So traditionally, we give demos to the robot by teleoperating the robot, but this way is very inefficient. So we use a different way. So it's a very smart design. So first we use a Vision Pro to record people doing their normal job. And then in this case, the AI will understand the task. In the second phase, so we use a teleoperation technology to control the robot. But in this case, AI will understand how to use the body of the robot. But we only need a much smaller amount of data in this case. And then we combine these two, we call it co-training of the robot. So the AI already understand the task and they just need to transfer what the AI want to do to a particular robot. In this case, they have two benefits. One is, of course, it's much more efficient because we only need to deal with the robot in the second phase. And second, if we have another robot come in, we can also collect data for that robot and transfer our knowledge of the task to the second robot. My belief is that in the next 2 or 3 years, we will see those kind of intelligent robots powered by large foundation models in many applications. For example, in the household situation, in the landscape situation, in the road cleaning situation. So the reason is because the aging population. That means a lot of people need assistance and we may lack of people for certain kind of jobs. So this kind of robot will be in the perfect position for this purpose. And I would say we will see more and more people have the willingness to pay for this technology.